So in this video, I'm going to be talking to you about an important distinction that we need to make between certain kinds of arguments. Now, of course, in sections 1.1 and 1.2 up to this point, we've been talking about the different components of an argument, but then we need to learn here in 1.3 that, in fact, there are two very distinct kinds of arguments, and we need to understand how to distinguish one from the other. And that's mainly because for the rest of this course, we will be focusing on deductive arguments here. In section 1.3 and then, of course, in section 1.4, which follows it, inductive arguments are discussed, but after 1.4, we leave inductive arguments behind, though those are considered in another philosophy course called Critical Thinking. That's Philosophy 115, and you may be interested in taking that class as well. It's a very good complement for symbolic logic, but it doesn't approach arguments in this sort of abstract or algebraic way as we will be developing here in this course. So we need to understand the distinction between deductive and inductive arguments, and that's what we'll be learning about here in 1.3. So we'll have a fair bit of definitions here to consider. So that might be a little small, but I'll read it to you here. It says that deductive arguments, and maybe I'll make that a little bigger just so you can see that more easily. Let's see here. Yeah. That seems a little better. Back that up. All right. So deductive arguments are those which are written so that the conclusion is meant to follow necessarily from the premises. So in other words, if we assume the premises are true, in a deductive argument, the conclusion is at least supposed to be guaranteed to follow. And just note here, there is this very important parenthetical remark at the end of this definition, at least in the mind of the author of the argument. So in other words, what makes an argument deductive is that the author of the argument thinks that their conclusion is 100% guaranteed by the premises, if the premises are assumed to be true. So there are a couple things going on here. We're going to be assuming our premises are true, and then based on that assumption, we then, if we're offering a deductive argument, believe our conclusion is guaranteed by those premises. Now, this definition will probably be easier to understand, of course, when we look at some concrete examples of deductive arguments, but also when we look at inductive arguments, or at least the definition of an inductive argument, as we see here. So inductive arguments are those, as it's written here, inductive arguments are those which are written so that the conclusion is meant to only probably follow from the premises. In other words, if the premises are again assumed to be true, the conclusion is merely likely to follow. Again, notice the parenthetical comment here, at least in the mind of the author of the argument. So again, when an author sets out to offer an inductive argument, again, they ask us to assume the premises are true, and then they don't think the conclusion is guaranteed by those premises. They merely think the conclusion is probable or likely based on those premises. So there's an important distinction there. Deductive arguments offer, at least purportedly, a guarantee that their conclusion is true, whereas inductive arguments don't offer that kind of guarantee. They simply suggest that the conclusion is probable based on the premises. Now, in terms of what's going to help us to distinguish between deductive and inductive arguments, we can rely on the fact that there are very typical kinds of deductive arguments and a whole variety of those. And of course, in the text, Hurley makes some time to talk to you about each of these different types of deductive arguments. And then we have other types of what are called inductive arguments and some typical kinds that we'll see there. So we'll look at both of those as we proceed. So the first typical kind of a deductive argument would be an argument from mathematics, as you see here. And so I'll give you this basic idea or definition of the type, and then we'll look at an example here. It's a dated example, apologies, but nonetheless, it still works. So if somebody said Al Gore got 3 million votes in Florida in the 2000 election, and George W. Bush got 3,000,001 votes in Florida in the 2000 election, and then they conclude, therefore, right, here's our conclusion indicator word, Bush got more votes than Gore in Florida in the 2000 election. So what we can look at here is we can ask ourselves, well, why do they believe that Bush got more votes than Gore in the 2000 election, essentially it's because 3,000,001 is a greater number than 3 million, right? And of course, if those premises are assumed to be true, and I'm not saying that they are, but if we just for the moment assume that, then of course the conclusion would be guaranteed simply by virtue of the fact that 3,000,001 is always more than 3 million. Now, any kind of argument for mathematics then will be considered deductive, right? It's not as if 3,000,001 is usually more than 3 million. It's always more than 3 million, and that's where the guarantee comes from in this mathematical argument. But notice the parenthesis here at the end of arguments for mathematics where I say, but not statistics. So in other words, statistical arguments are often inductive, and here's an example of that, right? If we learn that 90% of all people are right-handed, and we say, therefore, so we're going to conclude something from that, therefore I bet that John Kerry is right-handed, well, that conclusion, that John Kerry is right-handed, is not guaranteed by the premise. It's simply likely, right? There's a 90% chance that if we don't know anything about John Kerry will be right-handed. So even though numbers are involved, and this is what we want to pay attention to here, even though numbers are involved in this argument, and it's relying on statistics, which of course is a branch of mathematics, that doesn't make the conclusion here guaranteed by the premise, and so it's best considered, of course, an inductive argument. And I would just note here that the phrase "I'd bet" also indicates that they think the conclusion is likely and not guaranteed by the premise. So, some more typical kinds of deductive arguments. Arguments from definition. So imagine you're at a buffet table, or imagine I am, and I say, oh, this condiment must be chow chow. As you can see, it's a relish of mixed pickles in mustard. So in this argument, the conclusion is actually coming first here, right? The conclusion is that whatever I'm looking at is chow chow, and I had to look that up, by the way. But it is chow chow. And why do I believe that? Well, I can see that it's a relish of mixed pickles and mustard, and so by definition, a relish of mixed pickles and mustard will be chow chow. And so if that's what the definition says, anytime we come to a conclusion based on what the definition of a word is, we're talking about a deductive argument. It's not like sometimes a relish of mixed pickles and mustard will be chow chow, and sometimes it'll be something else. It's just that if it meets those criteria, apparently, right, you can look it up yourself, that will mean that it is chow chow. All right, so arguments from definition, arguments from mathematics, these are both considered deductive arguments. There's another broad category of argument that is considered a deductive argument, and that would be when we are dealing with certain kinds of syllogisms. Now, this word syllogism here, it sounds like a technical term, and it doesn't get used necessarily all that often outside the context of logic or argumentation. However, it is simple. A syllogism is simply a deductive argument with two premises and a conclusion, of course. So it's just indicating that you have exactly two premises, and then you have your conclusion, and then it would be a syllogism. Now, there are going to be three kinds of syllogisms that we need to pay attention to here in terms of distinguishing between deductive and inductive arguments. The first kind will be what we call a categorical syllogism, and that's where each of the three claims in a syllogism, that would be the two premises and the conclusion, so each of the three claims will begin with the words all, no, or some, right? So that might take the form of all, right? All something, all something, all something. Might be all, no, some. Might be any of these combinations. But if each of your claims in that argument begins with specifically those words, you are definitely looking at a categorical syllogism. And while there might be a lot of other things to determine about what you're looking at, you can know then, if it's a categorical syllogism, it will be a deductive argument. Another kind of syllogism will be a hypothetical syllogism. And a hypothetical syllogism will be one where at least one premise is a conditional statement. Remember that a conditional statement is if-then. So if you're looking at an argument and one or both of the premises, because we're talking about a syllogism here, one or both of the premises is an if-then statement, you know then that you're looking at a hypothetical syllogism. Now, we'll remember, as we learned in 1.2, that if we're simply looking at a single conditional statement and nothing else, no two premises and conclusion, but just a single conditional statement, in fact, we're not looking at an argument at all. So what makes something a hypothetical syllogism is the fact that we have two premises, and at least one of which is, again, an if-then statement. Finally, and then we'll put all this into practice here on the next slide, but finally, we have what are called disjunctive syllogisms. So again, it's a syllogism, so it has two premises, and one of those premises in a disjunctive syllogism will be an either-or kind of statement. Okay, it'll be an either this or that. So, remember these definitions. I would encourage you to probably put these definitions on your note sheet for the first exam coming up, because they're going to be very helpful in terms of identifying deductive arguments of these types. And so let's just go ahead and put this into practice, right? So let's say I told you that the technology fee will go up anyway if the students reject the tech fee proposal. The students rejected the tech fee proposal, hence the technology fee will go up anyway. So clearly this is an argument. We have the word hence here as our conclusion indicator. And so we have two premises. The students rejected the tech fee proposal, and then the first one, the technology fee will go up anyway if the students reject the tech fee proposal. So we see, I hope, that the first premise here is an if-then statement. There's the word if way down there. It's an if-then statement, and anytime we have a syllogism, an argument with two premises, and one of them is an if-then statement at least, you know it's a hypothetical syllogism, and so obviously it's deductive then, right? And you can see that it's deductive because if the two premises were true, this person clearly thinks the conclusion is guaranteed by them. All right. All computers on this campus are outdated. Thus, all computers on this campus are useless, since all outdated computers are useless. All right. Again, we have the word thus here, a conclusion indicator. And so what follows that word thus will be a conclusion. We also see the word since, so we have a premise there. And of course, the very first sentence here is a premise. So once again, we're looking at a syllogism, two premises. And just note that the first premise begins with the word all, the conclusion begins with the word all, and the other premise here at the end begins with the word all. And so we're looking at one of these kind with the word all beginning each of the claims. It's definitely a categorical syllogism, and thus it is deductive, right? And again, the words all, no, and some lend you that sort of sense that the conclusion, if it follows some of these premises at all, is going to be guaranteed, right? When you say all, etc. So we have one more kind of syllogism, and of course that would be a disjunctive syllogism. And so in this case, we have, if I can purchase a Macintosh or a Dell, I won't purchase a Dell, hence I will purchase a Macintosh. And so in other words, what's going on is you have two options, and you're taking away one of them, which guarantees that the other one must be the conclusion, or the one viable option there, right? So again, we have two premises here. I can purchase a Macintosh or a Dell, and then also I won't purchase a Dell. And one of those premises, the first one there, is an either-or statement, making it a disjunctive syllogism, making it therefore, of course, deductive, a deductive argument. The conclusion, if the premises are true, is being asserted as guaranteed, not just probable, but guaranteed, assuming those two premises are true.